Test the series for convergence or divergence. To test the series for convergence or divergence, notice we have three things happening right here. I do have the alternating between negative and positive happening. The top side is representing even numbers 2, 4, 6, 8, 10, and the bottom side is representing regular numbers but not starting at 1. So it's like regular numbers but shifted up to units. So we need to rewrite this with a summation notation or identify a sub n. In other words, we need to identify it and we'll go from there. To write this as a summation notation, I have the following. This equals to summation notation. We have negative 1 to the power n for the alternating signs. And we have even numbers on top. So I'm going to write 2n. And at the bottom side, just like n, shifted up to units to make it starting at 3. We need to start from n equals 1, not 0. Let's test it. When n equals 1, I have negative 1 to the power 1. That will give me the negative sign to start with. And the numerator is 2 times 1, and that's a 2. The denominator is 1 plus 2, which is a 3. So that should do it. Now this is our a sub n, which means this part right here is b sub n. When we use b sub n, we're thinking about the alternating series test. The alternating series test talks about having b sub n positive terms and looking after two things, two conditions, to have b sub n decreasing, and the second condition, have the limit of b sub n as n approaches infinity equal to 0. Sometimes it takes longer to find if it's decreasing, so you might want to go after the second condition, so you're going to have to go in order. Both conditions have to be valid to use the alternating series test. So we're going to use the second one for now, or we're going to go after the second one for now. So let's go after this right here. So to find the limit of b sub n as n approaches infinity to see if it's equal to 0, that will equal to the limit of what we identified as b sub n, that's 2n, over n plus 2 as n approaches infinity, which equals to the limit of the following. We will write 2n, n plus 2, and divide the top and bottom side by n. That's one way to do it. And here we go. So we have equal limit n approaches infinity 2 n over n, which is 2, n over n, which is 1, plus 2 over n. Clearly, this right here would go to 0 as n approaches infinity, and the limit of 2 over 1, or the limit will give me 2 over 1, which is 2, and clearly that is not equal to 0 as we were looking for. So we can't use the alternating series test. We don't need to go after the first part, but I'm going to go over it anyway, just for the practice of seeing or showing that it's decreasing or increasing. Before I attempt that, To find the limit here, you could think about the following. Notice this right here is a first degree over a first degree, so we have the same degree, and the leading coefficients are 2 and 1 right here. So 2 over 1 will give me 2, and that's this 2 right there. That's another quick way. Now let's go over the other condition. Let's use a different color for the first one. Let's go with black, this right here, to show if it's decreasing or increasing, which, as I said, we don't need to, but just for the practice, we could call it f of x, and that is 2x over x plus 2. That says f prime of x using the quotient rule will give me the following. We take the denominator and square it. We keep the denominator as is. That's x plus 2 times the derivative of the numerator, which is 2x. The derivative of 2x is 2. Subtract now the derivative of the denominator, which is derivative of x plus 2, gives me 1, times the numerator as is, which is 2x. Simplifying this, I get the following. We could use the distributive on the first part on top. That will give me 2x plus 4 minus 1 times 2x, which is 2x, over x plus 2 to the second. Of course, this cancels, and we end up with the simplified fraction. That's a 4 over x plus 2 to the second. And that cannot be negative, so greater than 0. That means it's increasing. So f of x is increasing. So both conditions are not valid. We need it to be decreasing, but it's actually increasing. A lot of ways you could do that, but this is a good way, which is a derivative, thinking about it as a function. If you think about it as a common sense, let's call it that way, we have the top part is 2n or 2x, and the denominator is x plus 2. Notice the top part is a straight line with a slope of 2, and the denominator is a straight line with a slope of 1. Clearly 2x has a higher slope, so when you divide numbers from a graph that is above the first graph, which is x plus 2, if you graph both lines, you'll see that 2x is above x plus 2, and that will give you a fraction that is getting larger and larger as you move on, which is increasing. It's interesting to see that as a graph also. So now, going back to our topic, staying focused, we found that the limit of p sub n equals to 2, which is not equal to 0. Well, that takes me back to a sub n, and we could say the following. Since the limit of a sub n as n approaches infinity does not equal to 0, and in fact the limit does not exist. Now, the series that is given to us, and we wrote the summation notation for it, diverges by the test for divergence, and that should do it. Let me give you an overview of this problem. So we have the following. We have the series that clearly we could see that it's alternating. So we're using the alternating series test. We identified b sub n to be two n over n plus 2 without the minus 1. And it came up to be not decreasing, and the limit was 2 over 1, which is 2, and that is not equal to 0. So we can't use this right here. If both conditions are valid, we say it's convergent, but it's not convergent. Here's more. We have a theorem that says the following. If the series is convergent, then the limit of a sub n equals to 0. The test for divergence says the following. If the limit of a sub n does not exist, or the limit of a sub n does not equal to 0, then the series is divergent. So this is what we used after we attempted the alternating series test. And that should do it.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.